Welcome to my channel. In this video, let us try to understand how to solve problems on spherical mirrors. Before I start, let us see some of the important aspects to remember in order to solve them. Number one, formulae. So, what are the important formulae that we need to solve problems? Number one, you have focal length. So, r is equal to 2f, from which you can find out focal length. Then you have the mirror formula 1 by f is equal to 1 by u plus 1 by v, which I derived in my last video, which helps to identify the position of the image. Then you have magnification, m is equal to h dash by h is equal to minus v by u, which helps to understand the size and nature of the image. Now, another important aspect is there are few key points to remember in order to solve these problems. Number one, sign convention. On this I made a specific video, you can watch it. In order to use these u, v, f, all these values, we need to know the sign convention. And then the ray diagrams to understand the position of the image, where exactly the image forms, either in the case of concave mirror or convex mirror. And all those values are tabulated and discussed in detail in my previous videos, and we need to remember all these points which we have to use in solving problems. I am sure after this session you will find solving problems easy. Now, what is the approach that we need? Understand the problem, read the problem carefully and understand, then identify the known, that means the given parameters, then identify unknown parameters, which means the parameters which we have to find out or calculate. Then connect them through an appropriate formula. What is the formula that we have? So, I have shown you all these three. So, these are the only three formulae which we will use in solving problems. Then simplify the numericals to get the answer. Now, before I proceed, let me just give you some tips on this. There is some simple for solving multiple choice questions or short answer questions, where you can quickly by reading the problem itself without actually putting the numbers and calculating, you can identify the position and nature of the image. So, what is that? I call that as a simple verification method. Now, what is that which we need to do? Identify what kind of a mirror it is, find out what is the focal length f, find out what is the object distance. Then if possible, draw the ray diagram. Then you can show the object position there with the help of object distance, and then identify the image position. By looking at these values, you can identify the image position, and if that is positive, then you have the image forming behind the mirror, virtual and erect. If it is negative, the image formed is real, inverted and in front of the mirror. All these things I have discussed in my previous videos, as I already mentioned. So, let us say, for example, you have this question. Find the image distance of a concave mirror for a focal length of 10 centimeters and an object distance given as 25 centimeters. Now, this is your concave mirror. For a concave mirror, focal length is always negative. So, minus 10. So, look at this. So, this is your, so to the left it is measured, therefore, it will be considered negative. So, focal length is minus 10 centimeters and object distance, object is always in front of the mirror, therefore, it is to the left of the mirror, therefore, it is also always negative. So, u is minus 25 centimeters and this is center of curvature C, which will be at 2f distance. Therefore, when f is equal to 10 centimeters, then center will be at 20 centimeters. Now, when the object is beyond C, I am showing you here in this example, object is beyond C. Image will be between C and F, between C and F, which means what? Between 10 and 20 centimeters. Image should be between, F is 10 centimeters, C is 20 centimeters. So, between 10 and 20 centimeters. And because it is downwards, the image is inverted and real. Therefore, your image distance also is in front of the mirror on the same side as that of the object. Therefore, V will be negative. So, without actually getting the exact value, you know the range of the value and whether it is positive or negative by just looking at this. So, this kind of a verification method will help you to immediately solve or answer your multiple choice questions or short answer questions for that matter. Now, we have identified. Now, let us, so these are the different options that are given. So, by quickly looking at it, can, because the image has to be formed between 10 and 20 centimeters, this will be wrong, this will be wrong. And because the image is negative, this is also wrong. So, the only possible answer is minus 16.67 centimeters. Without actually calculating, you can answer this question with D. Now, by substituting these values, let us calculate the numerical. How do we get this value? 1 by, so we will take the mirror formula. 1 by F is equal to 1 by U plus 1 by V. Now, F is minus 10 centimeters, so 1 by minus 10 is equal to 1 by minus 25. U is always minus 25 plus 1 by V, which implies I can simplify taking this to the right hand side, this one to the left hand side, and therefore I can take that becomes plus. So, 1 by 25 minus 1 by 10. So, that when I simplify I get 16.67 centimeters, that is between 10 and 20. So, 16.67 lies between 10 and 20. That is how you can solve. Now, another tip before I go to the next example is, for a convex mirror, we have seen, you can watch the previous videos, image is always behind the mirror and therefore it is virtual, erect, and image is always diminished, small. So, you identify VED. So, you can remember this VED. Now, image is always less than focal length, and also image is always less than the object distance. So, V is less than F, V is less than U, and V image is always virtual, erect, and diminished. So, using this simple tape, let us look at this example. I have a convex mirror and it is having a radius of 3 meters and located at 5 meters from the mirror automobile. So, object is located at 5 meters. So, find the image position. Find the image position. So, R is equal to 3 meters. R is 3 meters, that is 300 centimeters. Now, U is 5 meters, and of course, U object distance is always negative, so negative. Then you have radius given R, which is equal to 3 meters, that is R is equal to 3 meters. Therefore, F is equal to R by 2, I wrote here, which is equal to 3 by 2. So, that is 1.5 meters. So, you got 1.5 meters. Now, looking at this, your image should always be less than one focal length. So, image distance should be less than this 1.5 meters, and image should be less than U object distance, that is object distance is 5 meters. So, it should be less than 5 meters. So, you will get the, you can check the options given, if this is given as a MCQ, you can check the options and identify whether it is less than 1.5 and less than 5 meters, then you can check that answer. Now, substituting these values in the formula, mirror formula, 1 by f is equal to 1 by u plus 1 by v. So, 1 by v is equal to 1 by f minus 1 by u, and substituting by changing meters into centimeters, I can write 1 by v is equal to 1 by f. F is 1.5 meters, so I can write 150 centimeters minus 1 by 5 meters, so that is minus 500 centimeters. So, 1 by v is equal to, when I simplify this, it comes out to be 115 centimeters. So, which comes to 1.15 meter, which is definitely the image position which is less than 1.5 meters and which is also less than 5 meters. This is image object distance, this is focal length. So, this is how you can solve. Now, let us go to some examples. So, an object is placed 15 centimeters from a converging mirror and also a diverging mirror of radius of curvature 20 centimeters. Calculate the image position and magnification in each case. Now, what is a converging mirror? Converging mirror means concave. Diverging mirror means convex. Diverging mirror means convex. Now, let us first identify what are the given parameters. So, now what is given to us? U is given, an object. So, u is given, object distance is always irrespective of the mirror, it is always negative. So, minus 15 centimeters. So, this is object distance, and then radius of curvature r is given to us 20 centimeters. Therefore, f is equal to r by 2, I can calculate. So, 20 by 2, so that is 10 centimeters. Then what I need to calculate? So, this I need to calculate, v, image distance I need to calculate. And what else I need to calculate? I also need to calculate magnification. Okay. So, in a concave mirror, f is always taken negative, and in a convex mirror, f is positive, because focus lies in front of the mirror and it lies behind the mirror. So, now let us substitute in the mirror formula. So, 1 by f is equal to 1 by u plus 1 by v, and for I will put this as a and this is b. So, first I will solve it for a. So, for a, 1 by f is 10 centimeters. So, I will write this as 1 by f. So, minus 10, because f is minus for converging mirror. So, minus 10 is equal to 1 by u is minus 15 plus 1 by v, which implies 1 by v is equal to, I will take this minus 1 by 15 the other side, then it becomes plus. So, 1 by 15 minus 1 by 10. So, that can be written as minus 5 by 150, or it can be equated to minus 1 by 30. So, 1 by v is equal to minus 1 by 30, which implies v is equal to minus 30 centimeters. V is minus 30 centimeters. Then, what is m in this case? M is the formula minus v by u. Because heights are not given, we can use this formula. So, minus of minus 30 by minus 15. So, that is equal to minus 2. That is minus 2. And let us consider the case B for diverging mirror. Again mirror formula, 1 by f is equal to 1 by u plus 1 by v, and here f is positive, so I will write 1 by 10 is equal to 1 by minus 15 plus 1 by v. So, 1 by v is equal to, I will bring this side, so 1 by 15 plus 1 by 10. So, that becomes 25 by 150, so that is 1 by 6, which implies v is equal to plus 6 centimeters. So, the image distance is minus 30 centimeters for concave mirror and plus 6 centimeters for convex mirror, and m is equal to minus v by u, which is equal to minus of 6 by minus 15. So, that comes out to be plus 0.4, plus 0.4. So, here in this case m is equal to minus 2, here in this case m is equal to plus 0.4. So, this is the problem. Then we will take another example. An object is placed at a distance of 10 centimeters from a convex mirror. So, convex mirror of focal length 15 centimeters. Find the position and nature of the image. Describe what happens as the object is moved farther from the mirror. So, that part also is included. I will see towards the end. First, let us solve. Now, what are the given parameters? So, u is obviously object distance is always negative irrespective of the mirror. So, minus 10 centimeters, and convex mirror, it is given convex mirror, and therefore, focal length is plus 15 centimeters, focal length will be plus, and then we need to find out v and also nature and size of the image. So, let us first solve this using mirror formula. 1 by f is equal to 1 by u plus 1 by v, and so that is 1 by 15 is equal to 1 by minus 10 plus 1 by v, which implies 1 by v is equal to, I will take this to the other side. So, 1 by 15 plus 1 by 10, and that will be equal to 25 when you take LCM or simplify. So, that will be equal to 1 by 6. So, v is equal to plus 6 centimeters. So, the image position is plus 6 centimeters. The positive value of v indicates that the image is behind the mirror. Image is behind the mirror because positive. Now, let us calculate the magnification. Magnification is minus v by u. So, that is minus 6 by u is minus 10. So, that is equal to 0.6. So, m is equal to plus 0.6. So, positive value of m indicates, positive value of m indicates that, what does it indicate? The image is image is virtual and erect. Image is virtual and erect. Now, as we can see, m is less than 1, which implies the height of the image or size of the image will be less than the size of the object. H dash is less than h. In other words, we know that the convex mirror image is always virtual and erect. H dash is less than h means what? Image size of the image is smaller than object. That implies diminished. Now, let us look at the last portion of the problem. Describe what happens as the object is moved farther from the mirror. That means, when the object is moved farther from the mirror, that means u is tending to infinity. It is moving away from the mirror, then the image position tends towards focus. We have seen how with respect to the change in the position, image changes. While m tends to 0. M is less than 1, so m tends to 0. So, this is the description of when the object is moving farther from the mirror. That means u tending to infinity, then the image tends towards f. Then another case of a problem for a concave mirror, let us see towards this end of this video. Now, here we have an object of size 7 centimeters that is placed at 27 centimeters in front of a concave mirror of focal length 18 centimeters. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? So, what is the position of the image on the screen that we place? Then also find the size and nature of the image. And then, if the object is moved closer to the mirror, how would the screen have to be moved? So, we will discuss that. So, first of all, let us once again identify what are given. An object of size means h is given to us. H is 7 centimeters. Then, in front of the, so mirror is concave mirror, and object is placed in front of the mirror at 27 centimeters. So, u is always negative, so minus 27 centimeters. Then focal length is given to be 18 centimeters, and for a concave mirror focal length is always negative. So, let me put negative sign there. So, minus 18 centimeters. So, what is that which we need to find out? V is how much? What is the position of the image? Where exactly it is located? And what is the size and nature of the image, for which we calculate m. Let us take to solve the problem. Once again, mirror formula 1 by f is equal to 1 by u plus 1 by v, and 1 by f is 1 by minus 18 is equal to 1 by minus 27 plus 1 by v. So, 1 by v is equal to, when it goes to the other side, it becomes plus. So, 1 by 27 minus 1 by 18, which you get it as minus 1 by 54 when you simplify, which means v is equal to minus 54 centimeters. Therefore, the screen should be placed screen should be placed at what distance? At a distance of 54 centimeters. Where it should be kept? In front of the mirror, because it is negative. So, in front of the mirror, given concave mirror. Now, let us calculate the magnification in order to find out the, why do we need? In order to find out the nature and size. So, minus V by U, which is equal to minus of minus 54 by U is minus 27. So, this goes 2 times. So, you will get minus 2. M is equal to. So, the negative value of M indicates that image is real and forms in front of the mirror and in the same side as that of the object. Now, we also know that M is equal to H dash by H, which implies H dash by 7, H is 7, is equal to minus 2, which implies H dash is equal to minus 14 centimeters. The negative value of H dash what is H dash? It is the height of the image. Indicates negative value of H dash indicates that the image is inverted. That means below the principal axis, inverted. And H dash is 14 centimeters. H dash is greater than H, which implies image is enlarged. H dash is 14 and H is 7. Therefore, H dash is greater than H. That means image is enlarged. Now, look at the last part of the problem. If the object is moved closer to the mirror, if the object is moved closer to the mirror means what? U is tending towards F. Object U, object distance U is tending towards F, then the image position tends towards infinity. As you can see, image position tends towards infinity for U less than F. U less than F. Up to F, it will be at different positions of the image. Up to F, the object is moving from infinity towards F, image position will be moving towards infinity. But for object distance less than F, image is virtual. Image is virtual. This is the only case where you will find the virtual image in the case of a concave mirror. So, this is how you will solve the problems, and please post your doubts if you have any in the comment section. Until then, keep watching, keep learning. Thank you.